In this video, we will discuss the electrolysis of molten electrolyte by using inert electrode, either platinum or carbon or graphite. So we will focus on these two examples, electrolysis of molten lithium bromide and electrolysis of molten sodium chloride. So I don't want to refer to this slide. So let's move to the next this part. Okay. So electrolysis, we have two types of electrolysis. We have electrolysis of molten electrolyte and also electrolysis of an aqueous solution. So for today, we discuss electrolysis of molten electrolyte. Okay. So this molten electrolyte refers to the molten ionic compound. Okay. For example, we have NaCl or KCl or NaBr or PbBr2 or KBr. So any ionic compound in molten conditions, meaning that the state symbol of this compound is liquid. For example, NaCl in liquid form. Okay. To write the electrolysis reactions or the redox reactions, you first have to write the full equations. So let's see the first example. For examples, is the electrolysis of molten NaCl. So we first start with the equations. So equations, NaCl molten liquid form, when it melted, it produces Na plus and Cl minus. Okay, so next thing that we have to write is the diagram of the electrolytic cell. So we have beaker, we have electrode. One is positive, one is negative, and this electrode is connected by wires to the power supply. Okay, right, so this is negative, this is positive. So negative is the anode and the positive is negative is cathode, positive is anode, and the current or electron flow from anode to cathode. And don't forget the electrolyte. So electrolyte is NaCl molten, NaCl liquid. Okay. Number 3 is be able to write the equations or the ionic equations for both electrodes. So at cathode, the negative electrode, and at anode, the positive electrode. So cathodes means the cation attracted to it, and anodes means an ion attracted to it. So from the first step just now, the equations we have Na plus the cation and Cl minus is the anion. So Na plus will be attracted to cathode and the Cl minus will be attracted to anode because it's negative charge. As we know, at cathode, reductions occur. At anode, oxidations process occur. Okay, so reduction means accept electron. Na plus, the charge is plus 1, so it will accept 1 electron and it will reduce to Na metal. Okay, Cl minus, oxidation means it will lose electron. It will lose electrons, okay, to form chlorine gas. So it should be minus electron here, but we write the electron the other side. The the other side, so plus electrons. You have to make it balance. 2Cl minus is needed, so we also need 2 electrons. Okay. Next step is we should be able to write the overall ionic equation. So we can do this by combining the half equations at cathode and half equations at anode. But we have to make sure both having the same number of electrons. Okay, so at cathode only 1 electrons, at anode we have 2 electrons. So we have to times equations at cathode with 2, and we can rewrite it as 2Na plus 2 electron to give 2Na. Okay, and then from the second equations we do nothing, we just copy whatever we have from the previous part. Okay, we already ensure both having the same number of electrons. So we can cancel out this electron, and we can rewrite the equation as, okay, we just group them together. 2Na plus 2Cl minus, okay, to give 2Na plus Cl2. Okay, madam, can we write Cl minus first instead of Na plus? Yes, you can, as long as you group them together. Okay, left hand side with the left hand side substance or the reagent, and the product with the on the product side. Okay, now let's see the second example, the electrolysis of molten PBr3. Sorry, PBr2. My mistake. Okay. So first, we start with the equation. PBr2 liquid produce what ions? Pb2 plus and Br minus, and 2 Br minus because it must be balanced. Okay, second is the cell. Okay. Okay, just roughly draw it. So this is negative, this is positive, and label this is PBr2 liquid. Okay, there you go for the diagram. And next thing is the equations at cathode and equations at anode. Cathode is the negative terminal, anode is the positive terminal. So at cathode, the negative ion will be attracted. At cathode, positive ion will be attracted to it. So the positive ion is Pb2 plus. At anode, the negative ion is Br minus. The process happen at cathode is reductions, at anode is oxidation. So reductions accept electron. The gas is 2 plus, so it need to accept 2 electrons to form Pb solid. Okay, so Br minus need to lose electron to form Br2 gas by giving up 2 electrons. Okay, so next step is we write the overall equations or the overall ionic equations for these reactions, or we call it as redox reactions. So in order to combine, we have to make sure they both having the same number of electrons. So cathode already 2, anodes also 2, so we do nothing. Okay, so we just copy all the equations. Okay, the half equations at cathode, and then the half equation at anode. Okay, 2 electron, cancel, we can cancel out. Okay, and we can write the overall equation. Make sure you group them together. Reactant with created product with product. Okay. So what if you have aqueous solutions? What if you have aqueous solutions? The second category or the second types of the electrolysis. Okay, aqueous solutions. So we have to follow a certain rule in order to determine which ion will be discharged at cathode and at anode. So for the electrolysis of aqueous solutions, we continue in the next video.